Let's consider another exponential application, one in which we're measuring the intensity of light below the surface of water. And in this case, the model that we'll be using is I equals I naught, I with the subscript of 0, times K to the x power. And in this case, I and x are the variables, so I is the light intensity, I is the light intensity, x meters below the surface of the water, okay? So I and x are the variables. As x changes, I changes, and vice versa. So I naught and k, they are constants. So these guys are variables, I and x, they change. And I naught and k are constants. I naught is the light intensity, keep spelling intensity wrong, sorry about that, is the light intensity at the surface of the water. So that doesn't change. It's as you go deeper and deeper, the light intensity changes. And K is simply a constant dependent on water clarity. So that's going to impact how quickly your light intensity changes as you go deeper if your water's more or less clear. So that K constant takes that into account. Let's do an example. Let's say the light intensity at the surface is, I don't know, let's say 600 lumens. 600 lumens. At 20 meters deep, it is 100 lumens. Then we could ask the question, what is the intensity? What is the intensity at, I don't know, let's say 8 meters? That's a good question. And the idea is we have two data points. We have an initial intensity at the surface and we have an intensity at a different depth. We can use that to start to find the constants in our model. And then once we know the constants, we can use the model to find the intensity anywhere. And so let's take a look at what this looks like on a graph maybe. We've got the intensity here, and we've got the depth here in meters, and lumens maybe as LM, something like that, maybe capital LM. And the initially at the surface at 0 meters deep, our intensity is 600 lumens. And then at 20 meters deep, our intensity is 100 lumens. So, you know, our graph's doing this kind of thing. And approaching 0 lumens as you go deeper and deeper. And the question is, what is the light intensity at 8 meters? So what we're going to do is we're going to use the two data points that were given here and plug them into our model to solve for any constants that we don't know. So the intensity at x meters, well, we know at 20 meters, so we could say x is 20, the intensity I is 100. So I could plug in 100 for I, and I'm going to plug 20 in for x. And I also know my intensity at the surface is 600, so I naught is 600 times k, so we don't know our value of k, to the x, which is, well, when it's 100 lumens, our depth x is 20 meters. And now we need to solve for this constant k to get our model. So to solve for it, I'll divide by 600. 100 divided by 600 is 1/6. And now to undo a 20th power, we have to do a 20th root. So I'll do the 20th root of 1/6 has to be k. Now typically you do a plus or minus here, but we're interested in the positive k value in this case. So k, let's calculate this, is approximately, k is approximately 0.9143. And if you can't figure out how to do a 20th root on your calculator, that's the same thing as taking 1/6 to the 1/20th power, an exponent of 120. So you could do that, 1/20th, sorry. So we have our k value now. Once we have our k value, we can use it to write our model to solve the problem. So our model, we leave I as a variable. Our constant I naught is still 600. That's our intensity at the surface. That doesn't change. Times the k value we found, which was about 0.9143, to the variable of x, where x is the depth in meters. So now we can answer the question because we have a relationship between the intensity and the depth with the constants filled in. We want the intensity at 8 meters, so we're simply going to plug in 8 for our x value. Let's see here. And if we calculate that, it looks like we get about 293 lumens. I don't know the abbreviation for lumens, so let me just write it out here. So again, with these models, interpreting what it's saying, finding the constants may be necessary, so I naught and k, figuring out what those constants are, so that then you can construct the model to plug in an I or an x value that can change and find the other value.